In today's lesson, we're going to be looking at multiplying whole numbers. Looking at TEKS 5.3c, content objective, I can multiply using the standard algorithm. Language objective, I can explain my process for using the standard algorithm for multiplication. Essential question, what is another way to solve this problem? And I can answer that using the sentence stem. Another way I can solve this problem is... Multiplication's not new to us. We began learning this back in second grade, and when we did, we learned that multiplication was really just repeated addition. For example, I could have 2 plus 2 plus 2 plus 2, and I'm going to write it again over here, but I could have this as my problem, and what we could do, obviously, is we could just add it together. So 2 plus 2 is 4. I'll bring the rest down. 4 plus 2 is 6, bring the rest down, and then 6 plus 2 is 8. Another way that we could talk about this is we could say, well, I have 2 4 times. And the way I could write that is that I have 2 4 times, and of course I know that that's going to be 8. Another way that we could think of multiplication that we learned in second grade is that multiplication can be thought of as groups of, meaning that I have 4 groups of 2 and 4 groups of 2, so there's 1, 2, 3, 4 groups of 1, 2, 3, 4 groups of 2, so 1, 2, 3, 4, 5, 6, 7, 8. I have 8 objects. Another thing that we know about multiplication is that 4 times 2 and 2 times 4 will get me the same product. So if I had 2 groups of 4 instead of 4 groups of 2, 1, 2, 3, 4, 5, 6, 7, 8, I still have 8 objects. So 2 groups of 4 and 4 groups of 2 are going to give me the same product, in this case 8. A couple of important vocabulary words that we need to know is factor and product. Factors are the numbers that we multiply together. So my factors are 2 and 4, and my product is 8. So product is the answer to a multiplication problem. Factors are the numbers we multiply together. Also, we're going to talk in just a little bit about a partial product. And a partial product is just like it sounds. It's part of an answer, or part of the product when I multiply some factors together. Another way that I could think of multiplication is by using an area model. And so we also did this in 4th grade as well. So if I have this rectangle with a length of 4 and a length of 2, well, then it's going to be the area of that rectangle. So I have this set up in an array. Here I have 4 times 2, and that's going to give me 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 objects contained in this array, and so 4 times 2 or 2 times 4 will give me a product of 8. Alright, so we're going to be looking for some patterns in multiplication. So starting off here, I have 2 times 4, which is just 8. And what this is that's 4 ones times 2 ones. So both my numbers are in the ones place. And I'm going to get a product of 8 ones. Here, I have 2 ones times 1 1. So 2 times 1 is 2. But then I'm going to multiply 2 times 4, but really this is 4 tens. It's in the tens place. So 2 times 40 is actually going to give me 80. Standard algorithm, as we learned it, I just put my 8 here, but notice the 8 is in the tens place. That's 82. Another way that we could look at that is that it's 2 times 1, which is 2, and then 2 times 40, which is 80. And so here I have a partial product of 2, a partial product of 80, and I add those together to get 82. And so that's really what I did here. And so I think it's important to understand what we're doing if we lift up the hood of mathematics, if you will, and see what's really going on behind the scenes. And so that's what we're doing. Alright, so next we have 2 times 3, which is 6. 2 times 1, or 2 times 10, which is going to be 20. But 2 times 1 is 2, and then 2 times 4 will give me 8. And again, that's just 2 times 3, 2 times 10, and then 2 times 400. So 2 times 400 is 800. 26. So the same thing will work there, my partial products. Final example here on the lower level. So 2 times 2 will give me 4, 2 times 3 is 6, 2 times 1 is 2, and then 2 times 4 will give me 8. And so there's my answer of 8,264, or my product of 8,264. Alright, so looking for patterns in multiplication. So you notice I'm doing this all on grid paper. I definitely recommend either using grid paper or turning your notebook paper sideways so we have nice columns that help us keep everything lined up. So as we increase the amount of numbers that are in each of our factor, or increase the place value in our factors, it becomes more difficult to keep our numbers straight. So I'm going to recommend either using grid paper or using your notebook paper sideways. Alright, so for this first one, I have 4 times 24, but what I know about multiplication, 4 times 3 and 3 times 4 will get me the same product. And so I'm going to go ahead and apply that same strategy here and change this from 4 times 24 to 24 times 4. And so once I've done that, 4 times 4 will give me 16, and then I just have to do 4 times 2, which is 8, plus my 1 to give me 9. Using the other method we talked about a moment ago, 4 times 4 is 16, and then 4 times 20 is 80, and I have my two partial products of 16 and 80. When I add those together, I will get 96. So I get the same thing, and so I understand what's really happening behind the scenes. Again, standard algorithm, just writing it this way, the way that we're used to, is a little bit cleaner. All right, so first one solved. Next one, let's see if we can find the patterns and continue on with what we know. So 4 times 1 will give me 4. 4 times 4, 16. And then we do something that I like to call Tic-Tac Zero. I know that some of the 4th grade teachers actually teach a turtle method, and I had a student try to explain that to me previously. It sounded kind of violent, so Tic-Tac Zero is just a much prettier, less violent method. So if you like the turtle method, that's fine. I'm going to use Tic-Tac Zero. So Tick, I would cross off any numbers that are up here at the top, which I don't have any, so that's good. Tac, cross out my 4. Drop a 0. So Tic-Tac Zero. The reason I could drop that 0 is because I'm already done with this ones place. Now I'm multiplying my tens place. So I need to have my tens place available here. Alright, so 2 times 1 is 2. 2 times 4 is 8. I now have my two partial products, and I just add those together. 984 is going to be my product. Next example, 4 times 3 is 12. 4 times 1 is 4, plus 1 is 5, and then 4 times 4 will give me 16. Tic-Tac Zero. So I'm done with that one, ready to move on. 2 times 3 is 6, 2 times 1 will give me 2, and then 2 times 4 is 8. Add my partial products together. 6, 7, 8, 9. 9, so 9,912. Last example, it's just going to follow the same patterns. 4 times 2 will give me 8. 4 times 3 is 12. 4 times 1 is 4, plus 1 is 5. And then 4 times 4 is 16. Ready to move on. Tic-Tac Zero. 2 times 2 is 4, 2 times 3 is 6, 2 times 1 is 2, and 2 times 4 is 8. So again, the grid paper helps me keep everything lined up, so that way I make sure that I get a correct answer. So add my two partial products together. 99,168 for my answer. Now, just to connect what we're currently doing to previous learning, I want to look and see what happens if I were to do this with an area model. So I just took this problem up here and just moved it down here. So I have 4,132 times 24. 4 times 2 is 8. I have 1, 2, 3, 4 zeros. 2 times 1 is 2 with 3 zeros. 2 times 3 is 6 with 2 zeros, and then 2 times 2 is 4 with 1 zero. 4 times 4 is 16, 3 zeros. 4 times 1 is 4 with 2 zeros. 4 times 3 is 12 with a 0. And then 4 times 2 is 8. Now normally, what you guys have learned in the past is that you would add up your columns, and then you'd have your partial products, and then you just add your partial products together. Well, that would work, and that's fine, but instead of doing that, I want to see what happens if I add my rows. So I want to add horizontally instead. And so luckily with my place value, it makes it a little bit easy to do so here in this case. So that's going to be 8, 2, 6, 4, 0. So that was nice and easy. Here I have 16, and then in the hundreds place, I have a 4 and a 1, so that's 5 hundreds. And then 28. And I want to point out something really interesting. So if I notice my first partial product, 16,528, happens to be my same partial product here. My second partial product of 82,640 is my same partial product here. So my partial products end up being the same. So what does that mean? Well, what that means is standard algorithm and my area model, I'm really doing the same steps, doing all of the same stuff. The idea is that the standard algorithm is a little bit cleaner, a little bit neater, and that's why the TEKS wants us to know how to do that and have good mastery and understanding of how to do this, because it looks a little bit better and it works a little bit nicer, especially when we get to some of the other numbers. And it's just easier to keep everything nice and lined up in our columns than it is here with place value in boxes. So standard algorithm is what our TEKS want us to know. And so, but we notice it's really the same thing. And so here's a page from my book of knowledge where I explain how to multiply a 3-digit by a 2-digit. But again, as we saw with the patterns, it's really all the same. So my step 1 is to multiply the ones place by the top factor. So that's important. My ones place here in this factor, multiply that by everything in the top factor. And that's our first partial product. Step 2, Tic-Tac Zero. So Tic-Tac, add my 0. Step 3, multiply the tens place. So this place here by the entire top factor, and that gets us our second partial product. And then step 4, I just find the sum of my two partial products. I just add them together, and then I'm able to get my final product or my answer to my multiplication question. All right, so with that in mind, let's look back at our objectives, make sure that we've completed our learning for today. So my content objective, I can multiply using the standard algorithm. Yes, I can do that. That is a check. I can explain my process for using the standard algorithm for multiplication. Yes, I can. Essential question. What is another way I could solve this problem? So we looked at different ways. We looked at using area models or using the standard algorithm. So if I've done it with the standard algorithm, then I could use a different method in order to prove my answer a different way. And I can answer that another way I can solve this problem is by using this other strategy. So I've fulfilled all of my objectives. Now there are other ways too. So we could use base 10 blocks or different manipulatives, draw other types of models. But again, our focus is on the standard algorithm for this lesson, and so that's what I wanted to make sure we know how to do. And of course, we do, so we're ready to get some practice.